The two most dangerous numbers in the universe are threatening the end of physics. CERN has announced that the Large Hadron Collider LHCb experiment had revealed the existence of two new baryon subatomic particles. A deeply disturbing and controversial line of thinking has emerged within the physics community. It's the idea that we are reaching an absolute limit of what we can understand about the world around us through science. The next few years may tell us whether we'll be able to continue to increase our understanding of nature, or whether maybe for the first time in the history of science, we could be facing questions that we cannot answer, said Harry Cliff, particle physicist at the European Organization for Nuclear Research, better known as CERN. This is what he said during a recent TED Talk in Geneva, Switzerland. Equally frightening is the reason for this approaching limit, which Cliff says is because the laws of physics forbid it, quote unquote. At the core of Cliff's argument are what he calls the two most dangerous numbers in the universe. These numbers are responsible for all the matter, structure, and life that we witness across the cosmos. He says if these two numbers were even slightly different, the universe would be an empty, lifeless space, says Cliff. Number one danger, he says, is the strength of the Higgs field. And we have illustrations of the Higgs boson field. The first dangerous number on Cliff's list is a value that represents the strength of what physicists call the Higgs field, an invisible energy field not entirely unlike other magnetic fields that permeates the whole of the existence of the universe, the whole cosmos. And as particles swim through the Higgs field, they gain mass to eventually become the protons, neutrons, and electrons comprising all of the atoms that make up you, me, and everything we see around us, and without it, we wouldn't be here. We know with near certainty, that the Higgs field exists because of the groundbreaking discovery in 2012, when CERN physicists detected a new elementary particle called the Higgs boson, and according to that theory, you cannot have a Higgs boson without a Higgs field. But there's something mysterious about the Higgs field that continues to perturb physicists and like Cliff alike. Now, according to Einstein's theory of general relativity and the theory of quantum mechanics, the two theories in physics that drive our understanding of the cosmos on incredibly large and extremely small scales, the Higgs field should be performing one of two tasks, says Cliff. Kindly support my Patreon account. The daily posts are 5 videos daily, and they are totally different from what I have on my YouTube channel. Thank you so much for your support and that you find all my content so interesting. You'll find the Patreon account details in the description box. Either it should be turned off, meaning it would have a strength value of 0 and would not be working to give particles mass, or it should be turned on, and as the theory goes, this on value is absolutely enormous, Cliff says, but neither of these two scenarios are what physicists observe. Cliff says, in reality, the Higgs field is just slightly on. It's not 0, but it's 10,000 trillion times weaker than its fully on value, a bit like a light switch that goes stuck just before the off position, and this value is critical. If it were a tiny bit different, then there would be no physical structure in the universe, he says. Why the strength of the Higgs field is so ridiculously weak defies understanding. Physicists hope to find an answer to this question by detecting brand new particles at the newly upgraded particle accelerator at CERN. So far, though, they're still hunting. And the dangerous number 2, the strength of dark energy. Cliff's second dangerous number doubles as what physicists have called the worst theoretical prediction in the history of physics. This perilous number deals in the depths of deep space and a mind-melting complex phenomenon called dark energy. Dark energy is a repulsive force, and that's responsible for the accelerating expansion of our universe. It was first measured in 1998. And Cliff admits Still, we don't know what dark energy is, but the best idea is that it's the energy of empty space itself, the energy of a vacuum. If this is true, you should be able to sum up all the energy of empty space to get a value representing the strength of dark energy. And although theoretical physicists have done so, there's one gigantic problem with their answer. Cliff said, quote, dark energy should be 10,120 times stronger than the value observed from astronomy. This is a number so mind-bogglingly huge that it's impossible to get your head around. This number is bigger than any number in astronomy. It's 1,000 trillion times bigger than the number of atoms in the universe. That's a pretty bad prediction, he said. On the bright side, we're lucky that dark energy is smaller than theorists predict. If it followed our theoretical models, then the repulsive force of dark energy would be so huge that it would literally rip up our universe. It'll rip it apart. The fundamental forces that bind atoms together would be powerless against it, and nothing could even form. Galaxies, stars, planets, and life as we know it would not exist. On the other hand, it's extremely frustrating that we can't use our current theories of the universe to develop a better measurement of dark energy that agrees with existing observations. Even better than improving our theories would be to find a way that we can understand why the strength of dark energy and the Higgs field is what it is. Getting answers could be impossible. Cliff said, there is one possible way to get some answers, but we might never have the ability to prove it. If we could somehow confirm that our universe is just one in a vast multiverse of billions of other universes, then suddenly we can understand the weirdly fine-tuned values of these two dangerous numbers, because in most of the multiverse, dark energy is so strong that the universe gets torn apart, or the Higgs field is so weak that no atoms can form, Cliff said. And to prove this, physicists need to discover new particles that would uphold radical theories like string theory, which predicts the existence of multiverse. Right now, there's only one place in the world that could possibly produce these particles if they exist, and that's the Large Hadron Collider at CERN. And physicists only have 2 or 3 years left before CERN shuts the Large Hadron Collider down for upgrades. If we haven't found anything by then, Cliff said it could signal the beginning of the end. He said, we may be entering a new era in physics, an era where there are weird features in the universe that we cannot explain, an era where we have hints that we live in a multiverse that lies frustratingly beyond our reach, an era where we will never be able to answer the questions, why is there something rather than nothing? This is by ukfinanceyahoo.com on Bended Reality. Please leave your comments, and thank you for your support.